So here's a quick little video for you to practice with ionic compounds. Remember that ionic compounds are ones that have a metal and a non-metal. Keep in mind that that metal could be a group 1 metal, an alkaline metal, a group 2 metal, an alkaline earth metal, a group 3 metal like aluminum or gallium, or it can be a transition metal. And then it's also a nonmetal, which can also be a polyatomic ion. So there can be some different rules for doing that. So what I would suggest for you is that you get out your periodic table, your list of polyatomic ions, and pause the video and practice writing these formulas. All right, let's go. All right, so what about this one? Strontium and selenium. What's the formula? What's the name? So take a moment to find strontium. It's an alkaline earth metal, so it's in group 2. Selenium is in group 6A. It is a non-metal. All right, so did you come up with these for the charges? And then using that cross rule, cross them. Notice, of course, that these two equal out to be 0. A 2 plus and a 2 minus is definitely going to equal 0. And so we don't need any subscripts there. If at first you had put a 2 here and a 2 here, then hopefully you simplified it so that you don't have any numbers there at this point in time when you get your final formula. All right, let's try another one. So what would you say for this one? So hopefully you got your charges like this. You use that cross rule to cross them, and you came up with CaBr2 or calcium bromide. Notice that IDE ending. Our metal is always first. Its name hasn't changed. Here's another one. Great time to pause the video while you're looking on your periodic table for lithium and nitrogen. Hopefully you came up with this for your ions. As you cross those drop the charge and cross the numbers, hopefully you came up with this and the name lithium nitride. Here's another one. Again, great time to pause the video while you're looking for aluminum and sulfur. All right, and hopefully you came up with those ions. Again, aluminum is your positive cation, sulfur your negative anion. Aluminum sulfide. Ooh, now here's one with a transition metal, iron. You can see that I've told you the charge for iron right there in parentheses. So see if you can come up with the name and formula for this one. So there we go. Iron 3 chloride is our name. We're keeping that charge in there because this number 3, this Roman numeral, tells us the charge of iron. And so when it's in this formula, we still have to be able to tell people the charge of that formula. All right, here's another one. Now, if you're looking for hydroxide on your periodic table, you're not going to find it. Hydroxide is a polyatomic ion, so check your polyatomic ion chart. So did you come up with this? And hopefully you came up with, oh, where's calcium? Oh, I left my calcium off, I suppose. So this should be calcium hydroxide. Notice that when this 2 comes over, I put this OH in parentheses, and that's because calcium is a +2. So OH together is a -1. So I am going to need 2 of those so that this compound can equal 0. All right, let's try another one. Great time to pause the video while you're looking for potassium and phosphorus and figuring out the ions, then writing that formula. So hopefully you came up with K3P, potassium phosphide. Here's another one. Now, sulfate is kind of a dead giveaway. It is not on your periodic table. It is a polyatomic ion. So what do you get for the formula there? Yes, since there's a 2 plus and a 2 minus, that automatically is going to equal 0. So we are not going to need any subscripts to get that charge to be 0. All right, here's another one. Now keep in mind what that 2 plus means. That 2 plus means that that copper is a 2 plus polyatomic ion, or I'm sorry, transition metal, and it's bonding with nitrate, which is a polyatomic ion. So great time to pause the video. Now this nitrate can also, since it is a -1, it can be written with that minus charge right there, or it can be written with a -1. And sadly, as chemists, we do them interchangeably. And so after you cross those, hopefully you found this for your formula. And we're still going to be telling everybody that this was copper with a +2 charge. So I hope this helps you as you're working on naming and writing ionic compounds. Here are a couple of resources for you. So here's a little animation for you. If you want to take a look at that, that may help. Here's a little chart that may help you. So as you're coming up to a compound, and we've only done ionic compounds. So is there a metal or ammonium, which is also a polyatomic ion? And if there is, then it is an ionic compound. Our positive ion always goes first, which is our metal, or it could be ammonium. And the type 1 is the regular type. The type 2 are the transition metals. So these are our group B metals, and it's reminding you to use that Roman numeral to tell the charge. So these are our B groups, the transition metals. The negative ion, again, can be a polyatomic ion. If it's not a polyatomic ion, if it's just a regular single ion, you add IDE to the name. And for the polyatomic ions, you just use the name. And so that's where we are right here. We will be moving on to covalent compounds as well. Here's one more little resource for you. I call this the cheater periodic table. So you may want to snap a picture of that. Not only does this give the charges of so many of the ions for these transition metals, it tells you titanium could be titanium 4 or titanium 3, for example. It also gives you some of the common polyatomic ions. So I hope this video helps you as you're working on writing and naming ionic compounds.